Good morning, dear students. In today's video, we'll be studying about the family of salts and also about the pH of the salts. To begin with, let's take the example of a particular family comprising of grandparents, parents, and siblings. They will all have different names, but one thing common to them, to all of them, will be their surname. And we could take the example of an Agarwal family in which all the members, the grandparents, parents, as well as the siblings, they will have a common surname Agarwal, and hence they could be called the Agarwal family. And so different families will have different surnames which will be common to all the members. Similarly, our family of salts also have something which is common to them. Now, there are a number of salts here which I've written, and let me read out the names for you. The first one is sodium chloride, next is sodium sulfate, potassium nitrate, magnesium chloride, calcium chloride, potassium chloride, sodium nitrate, magnesium carbonate, calcium carbonate, potassium sulfate, and calcium nitrate. Now, when I was reading out their names, you would have heard some names being repeated or part of the name being repeated. For example, sodium here. In this salt, sodium is common. In this salt also, we have sodium, which is the common factor along with this salt. And in this salt also, we have sodium. So in these three salts, sodium is the common word. And so therefore, these three salts will belong to the sodium family. Now, sodium here is the cation. So it has, these salts have a common cation. So the members of the sodium family would be sodium chloride. We would have sodium sulfate, and we would have sodium nitrate. Now let's find another family, the potassium family. Now, who all are the members of the potassium family? The first one would be potassium nitrate. The next one, potassium chloride. And we have potassium sulfate. So these would be members of the potassium family. Common cation, potassium. So members of the potassium family. Similarly, we could have a common anion also. So if we have to take the anion chloride, now let's see who all will be members of the chloride family. The first one is sodium chloride. The next one would be magnesium chloride. The next one, calcium chloride. And we have potassium chloride. So here we have a common anion over here, the chloride anion, and hence the chloride family. Similarly, we could have a sulfate family also in all those salts where sulfate is the common anion. The first one being sodium sulfate. The next one would be your potassium sulfate. And we would have calcium sulfate. So this is how we find out the members which belong to a particular family based on a common cation or a common anion. That cation or that anion would give the family its name. So I hope This is clear? Now, moving on to the next point here. A salt, as we know, is made up by a reaction between an acid and a base. When an acid and a base react to form salt and water, we have a reaction, a type of a reaction which is known as the neutralization reaction. So a particular salt is formed during the neutralization reaction between an acid and a base. So let's find out that in sodium chloride, which are the acid and the bases which are involved here. So the cation here will come from the base and the anion will come from the acid. So during the formation of sodium chloride salt, the acid which has been used is the hydrochloric acid and the base is the sodium hydroxide. The base is sodium hydroxide. Let's take the next example, that of sodium sulfate. Now here the acid will come from the anion, or rather the anion will come from the acid. So the acid here will be sulfuric acid and the base which is involved for the formation of sodium sulfate would be sodium hydroxide. Let's take the third example, potassium nitrate. The acid which is involved is nitric acid. The nitrate anion would come from the nitric acid and the base would be potassium hydroxide. So this is how we find out the acids and the bases which neutralize one another to form a particular salt. Let's come to our next topic of pH of salts. And for this, I have written down for you certain examples of strong acids and weak acids, strong bases and weak bases. The strong acids here are HCl or the hydrochloric acid, the nitric acid and the sulfuric acid. A weak acid would be acetic acid, carbonic acid and phosphoric acid. The strong bases, sodium hydroxide, potassium hydroxide and calcium hydroxide. Weak bases would be ammonium hydroxide, aluminium hydroxide and copper hydroxide. Now children, we've already studied how a particular acid or a base is categorized as being strong or as weak. Now once again, let's recapitulate. A strong acid will dissociate into the hydronium ions and these negatively charged anions, when dissolved in water to a very large extent, and it is 100%. So in the case of hydrochloric acid, why is it categorized as a strong acid? Because 100% of this acid is going to ionize or dissociate to form hydronium ions and the chloride ions. The nitric acid would 100% ionize in water to form hydronium ions and the nitrate ions. Why these are known as weak acids? Because ionization is partial. That means maybe about 50% or 40% or 60% depending upon which acid it is. Those many molecules will dissociate into ions. The rest will remain in the molecular form. Similarly, a strong base would ionize in water to give 100% dissociation into the positive and the negatively charged OH ions. And weak bases would partially ionize. That means 100% of these molecules are not going to ionize. So that is how we categorize acids as strong or weak, or bases as strong as weak. Now let's see when a strong acid reacts with a strong base, what happens? So of course, the salt is going to be formed. The salt which is going to be formed will have a pH of 7. That means it will form a neutral salt and water. If we take the example of a strong acid such as HCl and a strong base such as NaOH, it's going to form the salt NaCl and of course the molecule of water. Here this salt NaCl has a range of 7, has a value of 7, and it falls in the neutral range of the pH. A strong acid, when it combines with a strong base, it gives rise to a neutral salt. Similarly, when a weak acid, now let's take the example of acetic acid, CH3COOH. Now this combines with a weak base. Let's take the weak base. The example would be that of ammonium hydroxide. Now what would happen? This would form a salt, ammonium acetate, NH4, CH3COO, along with water. This salt also has a pH value of 7 and hence it is a neutral salt. So a weak acid, when it combines with a weak base, it forms a neutral salt. Now let's take the example of a strong acid such as sulfuric acid. Now when this combines with a weak base, let's take another example of aluminium hydroxide. This will form an acidic salt, aluminium sulfate, along with water. Let's first balance this. Okay, now we have a balanced chemical reaction taking place. A strong acid such as sulfuric acid combining with a weak base such as aluminium hydroxide gives rise to an acidic salt, and the pH of this salt is 3, and of course water molecules. Now what happens when a weak acid combines with a strong base? Let's take the example of a weak acid, carbonic acid. This combines with a strong base, our very common base of sodium hydroxide. It's going to produce the salt sodium carbonate and water. Now this sodium carbonate is a basic salt. Why? Because the pH falls somewhere between 11 to 12. The pH value is this. Now once again, when a strong acid combines with a strong base, it forms a neutral salt, because equally the strength of The strong base is neutralized completely by that of a strong acid. So a neutral salt is formed. When a weak acid combines with a weak base, again a neutral salt will be formed. When a strong acid combines with a weak base, the acid is strong here, the base is weak, the salt formed is acidic in nature. When we have a weak acid combining with a strong base, the salt will be basic because the base is strong. Now children, you must have noticed different kind of arrows which I am using here to represent these neutralization reaction. How is it that you get a neutral solution here, a neutral solution here, an acidic solution here, and a basic solution here? This is due to hydrolysis of salts. Now, what do you mean by hydrolysis of salts? If you see the salts over here, they are all ionic in nature. That means in water, they are going to dissociate into the positively charged cations and the negatively charged anions. All of them are going to dissociate into ions, and when they dissociate into ions, they are going to interact with the water molecule here, and they will regenerate the base and the acid. So this kind of an interaction between the cations and the anions, or cations and anions with the water molecule, to give you back the acid and the base, is known as the hydrolysis of the salt. And it is due to this hydrolysis, or this combination with the water, which this salt undergoes. The ions of the salt, they are going to interact with the water molecules, and that is known as hydrolysis. So when this salt is going to interact with the water molecule, it's going to form again the acid and the base, which are of equal strength. Both are strong. So therefore the salt, this whole solution is neutral, and we call it a neutral salt. Similarly here, this is also a neutral salt, and this is acidic. Why? Because when this is going to ionize, recombine with this, it's going to interact with the water molecule, and is going to regenerate the acid and the base. The acid which is going to be produced is a strong acid. So therefore, this solution is acidic in nature. And in this case, when the sodium ions and the carbonate ions, they are going to interact with the hydronium ions and the hydroxide ions to regenerate the base and the acid. The base which is going to be produced is a strong base, sodium hydroxide, and hence the salt is also going to be basic. So that is all for today, and thank you very much.